I'm here with Dr. Romano to do a video on percent change.
Hi, I'm Dr. Romano. I'm professor of organic chemistry here at Romano Scientific and the creator of the Orgoman products and the author of the DAT Destroyer book. I'm here today. We're going to do another word problem involving percent change with Professor Blois. Professor, if you can show us some good problems, this looks like this is going to be one hell of a question.
It is one hell of a question.
All right.
Professor Blois here. Let's read it. There are three questions here in front of us. Let's read the first. Bob weighs 50% more than Art, and Carol weighs 20% more than Bob. By what percent is Carol's weight larger or smaller than the combined weight of Art and Bob? Okay, before we do this, I want to make a comment about percent change. If we have two values, like an old value of x and a new value of x, the percent change from the old to the new value of x is given by this. Percent change is equal to the new value minus the old value, and in the denominator, the old value, and then times 100%. But notice the positioning of the old value. New minus old in the numerator compared to the old in the denominator.
Should that be times 100, Professor, or is that 100%?
100%.
Okay.
Yeah, times 100%. And then we get the percent. Okay, so now for this problem, let me show you a little trick you can use. Bob weighs 50% more than Art. Carol weighs 20% more than Bob. Let's make up a number to make the problem easier to deal with in more tangible terms. So let's say that Art weighs, we'll make this up, he weighs 100 pounds. All right? We have a tangible number to deal with. Well, look, Bob weighs 50% more than Art. So how much does Bob weigh? 150 pounds, right? Okay, we have something, solid to deal with now. Carol weighs 20% more than Bob. All right, so Carol is going to weigh 20% more than Bob. What's 20% of 150? Well, that'll be 1/5 of 150, which is 30. So it'll be 150 plus 30, and that'll be 180 pounds. Okay, so it's a nice, this is something, a technique you can apply to a number of other problems by making up values, especially when you're dealing with percents, so you're dealing with tangible values. Okay, now let's get the percent change here. What's the, what are we asked for? The percent of Carol, what percent is Carol's weight larger or smaller than the combined weight of Art and Bob? Well, we see that Art plus Bob is equal to 250, right? And Carol is 180. So the percent change, right, the percent difference is going to be the weight of Carol minus the weight of Art and Bob compared to the weight of Art and Bob, right? Corresponding to the formula for percent change that we discussed before. So this is going to be what? 180 minus the combined weights of Art and Bob is 250 divided by 250. All right, 180 minus 250, well, that's going to be negative 170. So we're going to write over here negative 170 over 250. So the fact that we have a negative means it's going to be less than, right? It's going to be a percent smaller. So this is going to be, we'll cross out the zeros here. We have negative 17 over 25. We want to make this out of 100, so we'll multiply the fraction by 4 over 4. 17 times 4 is what? 68. Let's see. 25 times 4 is 100, and 17 times 4 is what? 17 plus 17 is 34, 68, and that's going to be negative 68%. Okay, so Carol's weight is 68% less than the combined weights of Art and Bob. And that's our solution. All right, let's go to the next problem. Compared to last year, the price of gold this year went up 30%, and it's expected to decrease by 30% next year. What is the percent increase or decrease in next year's price of gold as compared to last year's? Well, at first blush, look at this problem, you would say, well, the price goes up by 30%, then it goes down by 30%. Isn't it going to be the same price? Not quite. because the amount that you're applying the 30% to after the increase is going to be different from the amount you're applying it the 30% in the first situation. So let's say last year, and again, here's another technique, the same technique. Let's just make up a number. What is the price of gold last year? Let's just say it's $100, like $100 an ounce. Okay, so this year, right, the price goes up by 30%, and that's easy to calculate. That's 100 plus $30. So what is the percent increase or decrease in next year's? Next year, the price is going to go down by 30%. So that means it's 130 minus 30% of 130, or another way of doing that is say we're going to take 70% of 130. Okay, so that's equal to 0.7 times 130, and that's going to give us 91. All right. Well, actually, we don't need to do any more calculations. Since the original value is assigned to be 100, everything is measured in terms of, with respect to 100, so we're already dealing with percents. Percent is a number taken out of 100. So next year, the price of gold is 91%, so the percent decrease is going to be 9% as compared. Next year's price is going to be 9% less as compared to last year's. All right, now what if the situation were reversed? What if the price of gold this year, as compared to last year, this year, the price of gold went down by 30%, and then is expected to increase by 30% next year? It's exactly the reverse of the problem that we just stated. So let's do the same thing. Last year, the price of gold is 100%. Okay, this year, the price of gold is going down by 30%. So down by 30% means it's going to go down by $30. So this year, the price of gold is $70. Next year, the price of gold is going to increase by 30%. So what does that mean? We're going to multiply that by 1.3, the 1 representing the base amount, plus the 30% that is going to be increased. So 1.3 times 70 is equal to 91. So what do we find out? It's the exact same result. Even though the price went down by 30% and then went up by 30%, the difference between the two prices is that there is a 9% decrease in the price of gold over that period of time. Okay, that's the problem.
I think that was a great problem, what I really liked. I'm sure there's going to be one of the budding entrepreneurs calling you out on the price of an ounce of gold. I believe it's 1,300.
Is it really?
Around there. But the one thing that I liked, and hopefully everybody looked, is think simple. Use simple numbers. Mm-hmm. And I noticed when you pull a number out of thin air, you like the number 100. It's a nice, easy number to work with. In chemistry, I like to use the number 10. Like 10 grams or something, like we do in the DAT Destroyer. All right, guys, this wraps up this video with the professor. I hope you got something out of it. You'll see more questions just like this in our Math Destroyer. Good day to you. Bye-bye.